Hello everyone, welcome to SANGAM tutorials SP Gubbi online classes for NCERT 10th standard and CBSE 10th standard. So in the previous session of mathematics, we had proved the Thales theorem. So it states that if a line is drawn parallel to a side of a triangle, then it divides the other two sides proportionately or proportionally. So it is famous theorem, it is called Thales theorem or basic proportionality theorem. So here the reason for proving this theorem is we had a confusion, that is, in order to prove two triangles to be similar, whether we have to prove both the things, that is, one is whether we have to prove that both the triangles are equiangular, and also we have to prove that their corresponding sides are proportional. So for any two polygons with same number of sides other than triangles, both the conditions are required to prove that the polygons are similar. But in case of two triangles, both the conditions are not necessary, because if two triangles are equiangular, then automatically their corresponding sides will be proportional. So therefore no need to prove the second one. So if in two triangles if the corresponding sides are proportional, automatically the triangle will be, both the triangles will be equiangular. So no need to prove that they are equiangular again. So out of two conditions, one condition is enough to prove that both the triangles are similar. So if two triangles, so this is my conclusion statement. If two triangles are equiangular, then they are similar. Done. It is understood that their corresponding sides will be proportional. So if the corresponding sides of two triangles are proportional, then the triangles are similar. It is understood that the triangles are equiangular. So in the sense, both the conditions are not required, just one condition is enough to prove that any two triangles are similar. So by using Thales theorem, that is basic proportionality theorem, we have proved that. So we took a triangle, we had drawn a line parallel to a side of a triangle, so that that line intersects the two sides of the triangle at two distinct points. Then we proved that the line divides the other two sides of the triangle proportionately in the Thales theorem. Right. So it is very, very important. It is for 4 marks in your examination. Please practice that by changing the names. That is, for the diagram, change the name of the vertices. That is, if you take triangle ABC, take it as DEF. Draw a line EF parallel to parallel to one of the side of the triangle. Try like this. So you will not be constrained to a single diagram. So go with different names of the diagram. Try your own, so that you can get the concept of the triangle, not by hearting the triangle, that is theorems. So usually most of the students, what I see, they by heart the theorems. So in most of the exams, during the evaluation process, I have seen a very funny thing. Entire theorem they have presented, but without diagrams. Without drawing diagrams, they have presented the entire theorem. So it's not that the diagram was there in their mind or through imagination they have done it. So that's purely the student has by hearted the theorem and he has presented that. So when I ask him, sir, where is the diagram? He tells me that, sir, I forgot it. Forgot to write the diagram. See, this is not the way of learning geometry. It's a pure mathematics. You have to learn conceptualized. So if that is a thing, you will survive in mathematics. If you go by hearting the theorems, that's not the way. You have to understand the concept and the logic presentation in the proof. The proof plays a very important role. Understand the proof, write the reasons wherever possible for the steps in the proof, so that the presentation becomes more good. Right. So with these things, we will get into today's concept. So homework, I'm seeing that most of the students are not doing the homeworks, so please do the homework. Send to me through the WhatsApp. Right? Only in yesterday's WhatsApp, I had told you that to solve, that is to practice the theorem by giving different names to the diagrams. So some 3 to 4 I have just done it. So please see that. you are up to date. Don't ignore. Time is yours now, but one time will come where you don't get any time for the preparation for the examination. At that time you may face a lot of difficulty. So be updated, be with the teacher. Always be with the teacher. Right. Okay. So in today's concept we will be going with the converse of basic proportionality theorem or Thales theorem. So what is this actually? So in the statement, that is in the theorem, in any triangle, if a line is drawn parallel to a side of a triangle, then it divides the other two sides proportionately. So in that statement we had two parts. So at the beginning of the theorem I convinced you this. So first part of the statement is called as the hypothesis and second part of the theorem is called as conclusion. So here in an enunciation or a statement, what we have as Thales theorem, the statement of the Thales theorem, we take it here. We convert the hypothesis of the Thales theorem into conclusion and conclusion of the Thales theorem into hypothesis. So we do reverse of that. So we will convert the hypothesis into conclusion and conclusion into hypothesis. Right? So here converse, that's the same thing. The meaning of converse of a statement is the same thing. Conversion of the hypothesis of a given statement into the conclusion and converting the conclusion into hypothesis. That is, we are doing the reverse of the statement. If a line is drawn parallel to a side of a triangle, then it divides the other two sides proportionately. That is the theorem. Right? So here what we do, if a line divides any two sides of a triangle proportionately, then we are going to prove that it is parallel to the third side. So if it is parallel to the third side, then it divides the other two sides proportionately. That's the theorem. If it divides the two sides of the triangle proportionately, then it is parallel to the third side. This is the converse. So hypothesis becomes conclusion and conclusion becomes hypothesis. So here also we are going to prove this. So this will be for 2 or 3 marks in your examination. So it's a simple theorem, very simple theorem, but you have to practice this. This statement can be asked for 1 mark in your examination. State the converse of BPT, state the converse of basic proportionality theorem, or state the converse of Thales theorem. Very simple. If a line divides any two sides of a triangle proportionately, okay, works. If a line divides any two sides of a triangle proportionally, in a sense, what's in your mind now? Which geometrical figure you are getting into your mind? So here you are getting a triangle. So imagine a triangle. So in that triangle, already a line divides the two sides of the triangle proportionately. It's already dividing it. So then that line will be, then it means the line. It is parallel to the third side. The line is parallel to the third side. So in my mind I have a triangle. So reading the hypothesis part of the statement. So I have a triangle in my mind. So I will go with the diagram. So these things what I am writing, statement, diagram, to prove that all these things, I am not writing as to make the theorem look very good and presentable, not like that. It is the procedure you have to follow. Right? So let us go with the diagram. I have a triangle here. Okay, I will take it as triangle ABC. I will name the vertices as ABC. I will select these two sides, AB and AC, and let DE be the line. DE be the line which divides these two sides of the triangle proportionally. It's dividing. This line DE divides these two sides of the triangle proportionally. So that's the hypothesis. If a line, so line is here, divides any two sides of the triangle. So these are the two sides of the triangle proportionally. So that is the hypothesis. Then if to then, what you read in a statement, that's called hypothesis. And the remaining part of the statement, which is after then, it is the conclusion. So by taking the conclusion, you have to write to prove that. Okay. So we will write the description of the diagram. It is called as the data. So data goes like this. So whatever you see in the diagram, you will write it. That's all. So if a line divides any two sides of a triangle, so name the triangle. So in triangle ABC, a line divides any two sides of a triangle proportionately. So DE divides AB and AC. DE divides AB and AC in the same ratio. So this can be mathematically written as AD by BD is equal to AE by EC. So that means the line DE divides AB in the ratio AD is to BD, and the line at this point, that is E, it divides the side AC in the as AE and EC. So here the ratio between AD and BD is equal to AE and EC. So that is, this line divides these two sides of the triangle proportionally. So that is done. Next is you have to prove what is to be proved, and then that's means you have to write what is to be proved. So then it is parallel to the third side. Which one? It means the line. So DE is parallel to BC because BC is the remaining side. So these two sides are busy getting divided by this line. So then BC becomes the third side, that is remaining side. Okay, to prove that DE parallel to BC, right? So as the data is insufficient, we will have to go with an extra construction here. So now, so this is very important construction. So draw BM. Okay, we'll take this. Draw BM parallel to DE. Now already DE is parallel. That is already DE is parallel to BC. If a line divides any two sides of a triangle proportionally, then it is parallel to the third side. So actually DE, let us write DE parallel to BM. So we will construct this. So draw BM parallel to DE because DE already exists. The extra construction what we are doing is BM. So therefore draw BM parallel to DE. Right? So we will go with the proof. So this is the very important part of the theorem. Right. So please follow. Very, very important. Now let us select triangle ABC for the first time. Triangle ABC. Now, in triangle ABC, this one, DE is parallel to BM. DE is parallel to BM. So therefore, in triangle ABC, that is in triangle ABC, DE is parallel to BM. So therefore, AD by BD, that means we are applying Thayer's theorem. In triangle ABC, BM is parallel to DE, that is DE is parallel to BM. We have written that. So here, according to Thayer's theorem, if a line is drawn parallel to a side of a triangle, then it divides the other two sides proportionally. That is Thayer's theorem. So we will apply Thayer's theorem. So AD by BD is equal to AE by EM. AE by EM. So AD by BD is equal to AE by, that is AE by EM. So this is according to, take it as equation 1. So this is according to Thayer's theorem. This is according to Thayer's theorem. Okay. So now, here in triangle ABC, according to the data, already we have AD by BD is equal to AE by EC. That's according to data. But AD by BD is equal to AE by EC. Take it as equation 2. That's according to data. Right. I hope you understood this. It's a very important part of the proof. Right. So now, here, from equation 1 and 2 things, these are the two things, AE by EM and AE by EC are the two things equal to the same thing. If two things are equal to the same thing, then they are equal to one another. So that's by axiom what you have learned in your 8th and 9th standard geometry, basic geometry. So from equations 1 and 2, from equations 1 and 2, AE by EM is equal to AE by EC. So So here AE and AE cancels. So we are remaining with 1 by EM and 1 by EC. So let us take reciprocals for this. So it becomes EM is equal to EC. We got a result, that is EM is equal to EC. Now check that result in the diagram. So according to the result what we have got in the diagram, EM is equal to EC. So here EM is equal to EC means M and C are not two different points. M and C are not two distinct points. So here as EM is equal to EC, therefore point M and point C must coincide. They are not distinct, they are the same points. So according to the result what we have got, EM is equal to EC. So therefore point M and C are not distinct points. Distinct points. They are same points. They are same points. So now, instead of writing EM is equal to, that is, as EM is equal to EC, M and C are not distinct points, they are one and the same. So therefore, AD by BD will be equal to AE by EC. So if this is the thing, then DE should be parallel to BC. So therefore, DE is parallel to BC. Hence it is proved. So this is the converse of basic proportionality theorem, which is very important. These are the method to prove this. So proof is very, very simple. So now we have to take equation 1 using Thales theorem, equation 2 by data, comparing that by an axiom. So we get this result. So if we analyze this result in the diagram, we get that is conclusion. Right. So this is important. You have to practice. Right. So now we will go with the corollaries of BPT. Corollaries of the statements which follow the theorem. So if the theorem states, it gives you a truth. So based on that truth, simple truths based on that, they are called as corollaries. They are the statements which follow the theorem. So in a triangle, if a line is drawn parallel to a side of a triangle, then it divides the other two sides proportionally. That is the theorem. So if a line is drawn parallel to a side of a triangle, it divides the other two sides proportionally. That proportionality may vary on different terms of mathematics. So these different proportionalities, they are in Thales theorem, they are taken as corollaries. So we will go with that. We have three corollaries: corollary 1, corollary 2 and corollary 3. All the three are very simple and you have to by heart this. You should be able to recognize that. You should be able to identify that. That's the skill here. Okay, let us go with corollary 1. Let us take a triangle. So in this triangle, let us call it as triangle ABC. So here let us take DE, which is parallel to BC. Now, so in triangle ABC, DE parallel to BC. If you hear this, anybody telling you, I have a triangle, in the triangle a line is drawn such that it is parallel to the third side. If anybody tells you this, in your mind it should come that, okay, something is getting applied on Thales theorem, something is getting applied on BPT, something is getting applied on corollary 1, corollary 2 and corollary 3. So out of 4 things you are going to get. But if a line is drawn parallel to the side of a triangle, means that you cannot guess the converse of BPT. Converse of BPT is, that is reverse. If a line divides any two sides of a triangle proportionally, then it is parallel to the third side. That is different. That's a different criteria, right? So here we'll go with this corollary 1. Now, so in triangle ABC, we have drawn DE parallel to BC. So according to Thayer's theorem, DE should divide AB and AC in the same ratio. That is, it divides AB and AC proportionally. So now, so in triangle ABC, DE is parallel to BC. So as in triangle ABC, DE is parallel to BC. According to Thayer's theorem, by Thayer's theorem, AD by BD should be equal to AE by EC. So this is according to Thayer's theorem. Now, I want AD to be in the numerator. I want AD to remain in the numerator, but AD should get added to BD and BD should remain in the denominator. That's the thing I want to do now. I hope you understood. Once again, AD should remain in the numerator, BD should remain in the denominator, but I want BD to be added to AD. The same thing should happen here also. So what is to be done for that? It's very simple. You have to add 1 on both sides. So add 1 on both sides. This is called as componendo. In mathematics it is called as componendo. So AD by BD plus 1 is equal to AE by EC plus 1. So 1, we understood that its denominator is 1. So here also we have denominator as 1. So for BD and 1, LCM is BD. AD by BD into BD is AD plus 1 by 1 into BD is BD. So you can see here numerator remains, denominator remains there itself, but denominator gets added to numerator. So if you want to do this, add 1 on both sides. That is okay. Here also the same thing happens. So EC, AE by EC into EC is AE plus 1 by 1 into EC is EC. Now, from the figure, what is AD plus BD? From the figure, AD plus BD is AB. That is AB by BD is equal to, what is from the figure, what is AE plus EC? AE plus EC is AC. That is AC by EC. So this is corollary 1. So what this means, that the ratio, if a line is drawn parallel to a side of a triangle, then the ratio of AB by BD, that is the ratio between AB by BD and AC by EC, is also same. That's also true. That's what I told you. AD by BD is equal to AE by EC is Thayer's theorem mathematically. AB by BD is equal to AC by EC is corollary 1 mathematically. So now we will go with corollary 2. Okay. Corollary 2. So we will take the same triangle once again. So we will take triangle ABC. We will draw DE parallel to BC, DE parallel to BC. We will see the other possible truth which follows Thayer's theorem. Okay. So now in triangle ABC, DE is parallel to BC. By Thayer's theorem, okay, AD by BD is equal to AE by EC. AE by EC. So this is according to Thayer's theorem. Right. Now, the thing is, right, you have to listen very carefully. I want the numerator and denominator in the same place, but I want the numerator to get added to the denominator. Just what I did there, I have to do it here also. But it is a reverse process, right? So now let us take reciprocal on both sides. Taking reciprocals on both sides. Okay, so that becomes BD by AD is equal to EC by AE. So this is by taking reciprocals on both sides. Now I will add one on both sides. Adding one on both sides, that is main component or integral. Okay, so BD by AD plus 1 is equal to EC by AE plus 1. So by 1 it is understood. So when you take LCM for AD and 1, so LCM is AD. BD by AD into AD is BD plus 1 by 1 into AD is AD. So you can see here, numerator, denominator remains there itself, but denominator gets added to the numerator because we have taken reciprocals. So is equal to AE and 1, that is LCM is AE, EC by AE into AE is EC plus 1 by 1 into AE is AE. Now from the figure, what is BD plus AD? BD plus AD, it is AB. Therefore AB by AD is equal to, what is EC plus AE? EC plus AE is totally AC. So it is AC by AE. So this is corollary 2. Right. So let us read this. AB by AD, that is the full side by the upper limit and full side by the upper limit. So entire AB by AD ratio, entire AC by AE ratio is same. So we have three possibilities here, three consequences. That's what we call consequences of BPT. So once again I will repeat BPT. AD by BD is equal to AE by EC is called basic proportionality theorem or Thales theorem, that is the basic theorem. AB by BD is equal to AC by CE is corollary 1. Next, AB by AD is equal to AC by AE is corollary 2. Okay, until now you have got the things. That will go with the third corollary, corollary 3. Very important. Okay, let us get into corollary 3 now. This is triangle ABC. I have drawn DE parallel to BC. Now, this is very important. You have to by heart this statement. We have a statement for corollary 3. You have to by heart this. Here, we are going to draw a line parallel to a side of a triangle. So, according to Thales theorem, it divides the other two sides proportionately. That is one of the things. Yes, I accept that. But along with that, another one new thing happens. So what is that? When we draw a line parallel to the side, third side of a triangle, that is one side of a triangle, then it forms a new triangle. I hope you can see the triangle. That is triangle ADE is the newly formed triangle. When you draw DE parallel to BC, triangle ADE is the newly formed triangle. And triangle ABC will be called as the given triangle. So what the triangle we were having earlier with this, it is called as the given triangle, right? And triangle ADE is called as the newly formed triangle. So now the relation between the sides of the given triangle and the newly formed triangle, we will check out what are how the sides are related. So here, when you take the ratio between AD and AB, so AD is the side of triangle ADE and AB is the side of triangle ABC. So here AD and AB are the corresponding sides. They are the corresponding sides because when you draw this line and when you cut these two lines here, so these two lines are parallel to each other. So when you continue here, this line further, and when you continue this, and if this is the transversal, so if two parallel lines are cut by the transversal, then the corresponding angles are equal. So this angle will be equal to this. So in triangle ADE, angle AED is equal to angle ACB. That is, in the newly formed triangle, angle AED, and in the given triangle, that is angle ACB, are equal. So equal angles are called as corresponding angles. So sides opposite to equal angles are corresponding sides. Now in triangle ADE, this is the angle, opposite to this is AD, and in triangle ABC, this angle is equal to this. So therefore, in triangle ABC, side opposite to this angle is, that is AB. Therefore, for the triangle ADE, for AD, AB becomes the corresponding side. Right? So the same thing here also, these are the two parallel lines, this is the transversal. So for these two corresponding angles, because these two angles are equal, opposite to this side angle is AE, and opposite to this angle in triangle ABC is, that is AC. So for AE, AC is the corresponding side. So now this angle becomes a common angle for both the triangles. So for this common angle, in this triangle, this is the opposite side, and for triangle ABC, for this common angle, this will be the opposite side. So therefore, DE and BC are the corresponding sides. So when you take the ratio between these two, that is corresponding sides of the newly formed triangle and the given triangle, you will get that all the sides will be in the same ratio. That is, AD by AB is in the ratio 1:2, then this will be also in the ratio 1:2, this will also be in the ratio 1:2. So this can be summarized easily in the form of a simple statement. When a line is drawn parallel to a side of a triangle, then the sides of the newly formed triangle are proportional to the sides of given triangle. So this is corollary 3. So you have to behead this statement. So if a line is drawn parallel to a side of a triangle, then sides of newly formed triangle are proportional to the sides of given triangle. So this is the corollary 3. So mathematically we will write this. So AD by AB is equal to AE by AC. AE by AC is equal to DE by BC. DE by BC, or this can also be written as AB by AD, reverse. AB by AD is equal to AC by AE is equal to BC by DE. So this is the important result you have to remember. Right. So I hope you enjoyed the converse of basic proportionality theorem and all the 3 corollaries. So based on these results, we are going to solve many numericals, riders and identities. So this class is very important. This class and the previous class. So if you want theorem once again, don't ask me. Open the video, look into that. Any number of times you want. Right? So I hope you enjoyed the session. So in the next session we will be going with more and more numericals. So 10th June, it's a gentle reminder So 10th June is the last date for payment of fees. So please understand the situation, support the teacher by paying your fees, and please take it as a humble request from my side. So thank you everyone. Stay home, stay safe, keep learning.